welcome all to the second installment of the August series webinar, hosted by myself, Michael, and who's been here at One Spatial for a bit over 5 years now and started using it for me just not long after that. And today I'll be taking you through another one of the skills, I guess, done in spatial data science, which is geometric extraction from PDFs. And the example that I'll be taking you through today is the London Night Tube network over in the UK. So today I'll just quickly take you through the topics. So just briefly explain to you what the London Night Tube is, what sort of information we'll be grabbing from the PDF, the process of that in FME, and how we're dealing with unstructured geometry and text within the PDF, and then what the results of that are and what sort of processes are we going to have to do post extraction to tidy up the GIS file. So what is the tube? If you're wondering, the tube is a colloquially term that refers to the London Underground train network, which is actually the oldest metro system in the world. So it has 11 lines over 400 kilometers of track. It says 270 stations. I reckon it's far more than that. But anyway, it's a world-class service that, unless you're getting it at a very bizarre time, you pretty much don't need a schedule. There's over 1 billion journeys made, and the night tube, which is what I'm referring to, is basically the overnight service that runs on Friday and Saturday nights. So this is the London Tube network. It's also got the overground on there as well in the orange. Yep. So you can see, and then the tram link down the very bottom too. So you can see it's quite interwinding and quite gridded, not so much trying to get you into the center. So it's quite, a bit everywhere. It's a bit spaghetti-like, but you can also see those little, if you're wondering what the little symbols are with the red sort of arrows, that's National Rail, and that's another network again that goes over the top. So there's a lot of trains in London for sure. So then the night tube version of that is this. So it's just a trimmed down version with the more common lines that cover quite an even space of London. So that this is what, so the one that I did structured slightly differently, but it's essentially the same processes and go through the same thing. So what I guess we'll run through now is just what information is available in the PDF and what exactly can we extract from it. What we can extract from the PDF is pretty much going to be the desired outcome, because the reality is the map that we're using isn't spatially referenced. You can use it for maybe a couple of things of determining number of stops from somewhere or some useful things, but this was mainly just to sharpen our skills for PDF extraction, because it's just completely unstructured in many ways and requires you to put your thinking cap on to get to a solution and try and work it out. And it's just because it's unstructured, and particularly how I've shown you, like with text, you can't expect perfect results, and it's just accepting that there's a level that you can reach, but just obviously going to make things easier than having to do it completely manually. So the information we're going to be extracting is just what we can sort of see. So the station markers, we're just sort of doing a one-for-one realistically. So the station markers, the rail lines, the station labels, the accessibility of it. So what I mean by that is a disabled symbology on the stations that have disabled access, interchanges, which is a slightly smaller circle, and the zones as well. Then as just a comparison, this is the spatially accurate tube network. So a lot of the more ones you'd be looking at of like fueling the maintenance of the network and understanding, hotspots and traffic and those type of things are better to be done on these type of maps, which is not what we're extracting. So is quite much more limited, as we've said, to what you can do with it when you pull it out. So now I'll show you how I used FME to extract the geometry and text from the PDF. So before anything, you need to read it in, get out Data Inspector, and start finding out how it's reading in the various things you need to be extracting. So in this case, it's the text, it's the symbols, it's the geometry, it's the lines, and that will give you the clues on how you then need to process it to get to the end point of what you want. So in this screenshot, I'll just sort of explains a few of my points. So the text was often broken apart from their whole name. You can see, for example, with Oxford Circus, the little gap between the RD and the rest of Oxford is that little separations caused it to be read as different text fragments. And you can see the various ones. Some of them it's just for one word is one text anchor. It varies a lot for others. Those neighborhoods that it's in are varying in size. The disabled symbol that I showed you is it reads it in all the separate geometries that each part, so that needs to be sorted out. Train lines are segmented up rather than their whole network, and each zone is used essentially as like an alternating donut, so you get alternating zones that actually have no polygons, so that needs to be addressed as well. So plenty to be done. So this is a screenshot of the workflow that was required to fix everything up. So it's not crazy, but it's not nothing either. So I'll take you through what it looks like, or the structure of it. So up the top, we've got the station names, which is not really actually too complicated of a process. Then we've got the tube lines after that. Then the station markers, which are broken up into separate processes for disabled interchange with the circles, and then also the station markers with the rectangles. And then zones as well, which is a bit more faffing about. And then the final part of conflating it all together, exposing the right attributes before we then write it out into the GIS file. So kicking it off, the geometry filter is the way to do that with PDFs, and a great way to find out what's not, because you'll have instances where things should be, you might be trying to find out an area feature, but then you realize it's been read in as a line, and that's why you're not getting the results you want. So it's very good to use this filter to just assess everything. So in this case, the text was the station names, the line was train lines, and actually caught some of the station markers too, which I'll show you. And the area are the station markers, the disabled access symbols, the interchange stations, and the zones as well. So the station names, how that's going to come through is that it's a straightforward process, really. It was just exposing the hidden attribute of the FME text string, which will get it up there. And then how that gets read is it's quite fragmented out, some into whole words, some into just a couple letters, but I've just sort of explained it here that Seven Sisters is a station, but it's split over 4 word features. Same with Walthamstow Central's over 5. But then you do get some, like down the bottom of Pimlico, Brixton, Buckhurst Hill, that do read in naturally, so don't require too much fiddling around. And then I'm just going to show you graphically what we're sort of dealing with when we're trying to aggregate these together. So the same examples I showed you before, just grouping what the station name is. This is how it's reading in on the PDF. So there's a bit of a trend that it's going to be a rectangle styled neighborhood, but in varying sizes. And I mean, with how the maps sort of crammed together with the labels, it's going to get pretty messy. So aggregating those text fragments together, the process of this is by using the units of the coordinate system in the data inspector. You can sort of go across and go to different samples, maybe the one that's got the longest sort of spread out of text anchors, and figure out how many units it's going from one to the other, and up if there's rows of the label, like Lancaster Gate, for example, and that will determine what your neighborhood size is going to be. So the only problem is, though, is that with the varying sizes and how it's spaced out and positioned on the map, you're going to get issues with the varying sizes and long rectangles, because, for example, like the Hyde Park corner station name there, if we use that on Lancaster Gate, it's actually going to catch some of the Queensway label as well. So it's just a bit of a mess, to be honest. And I'll show you that exactly right now. So I've got a bit of a zoom up here of what's King's Cross and Pancras. So it's actually grouped it together just fine. No real issues with the neighborhood size, but we've got on top of that issue now, it has no knowledge of order of what these are coming in. So you get results like this where we're looking down the stations of just completely jumbled words. It'll give you an indication of what it's supposed to be, and if you can work it out, you can actually retype in what the station name is. But it's a pretty, it's not, it requires a whole lot of work. And a way you might be able to get around it is if you get really tricky and see that they're all in rows, you could do a coordinate extractor and use the axis values to say, well, if it all equals this, then order it from left to right. So increasing along the x-axis, then sort of use that as a sorter. But I guess that's sort of explaining how much work is required if you want to use FME to fix up everything, as opposed to just jumping into the post extraction and just fixing up the labels yourself. And now we'll move on to extracting the different tube lines. So to create the train lines, what we're doing is going through the data inspector of all the line segments out of the 148, because obviously we don't need all of those, and any of them that are segmented and broken apart, we need to find out those and include them. We need to filter for them essentially. So we go through and find those in the data inspector. We run everything through a count and find out what the count values are for the ones we want. And essentially what we do from there is we can run it through a test filter with a conditional value and say, if it enters of these, go to the certain output, and then that will be how we create the attribute for what tube line it is. And once we've got all of those correct, we then run it through an aggregator based on that value to make sure that we get a single line segment for the entire train line. Before processing anything, this is what the line segments look like when they've brought in. So you can see that the train lines are there, which is great. As long as it's there, that's the most important thing. But it's read in a few extra things, a couple of boxes, one of the zones of zone 2, 3, and some of the station markers as well. So the work that I just described in the slide before means that we can get it to a better process, which now looks like this after we've filtered everything out and aggregated them all together. So nice, clean looking set of train lines there. I'll now take you through how I extracted the station symbols. So one process I just wanted to touch on first before I dive into everything is the area geometry and how a process worked to get it out into the separate stations and zones to create their own sort of workflows. So first of all, really, we've got to get those lines that were caught as station markers and use the area builder to build those as station markers. But once we have that, using the area calculator was how I separated the zones away from the station markers to create their own data flows. And then obviously within that, again, you can use it for the different types of station markers, the disabled symbologies and the different zones as well. So using the test filter, we can isolate those value ranges of where the area calculations sit in. And that's how we can separate the different layers that need to be processed. And then the unfiltered output is really good as well. You'll be surprised about how many symbols that should be the same size as the others slip through because they're just not for some reason. So that was a key process in tinkering with those range values to make sure that everything's coming through properly. So the single line no disabled access, so as I was saying before, these are the ones that are just the little rectangles. It's only on one line. If it was a disabled access, it would be a circle with a disabled symbol on it. So, and then these are the disabled access symbols. So as you can see, they're three parts, as I was showing before. They're three parts that need to be aggregated together. and then the interchange and disabled access symbols. So this is for all of them, and how we'll be finding out what is disabled access and what is just the interchange is by doing an intersect relationship of both of them. So with the disabled and interchange stations, there is a little bit of a process going on here. So first of all, there's some stray letters at the bottom, some N's and some D's that just happen to have the same area as the circles that we got to get rid of using the counter and the attribute filter. Then with the neighborhood aggregator, we want to group the disabled symbols together as a single feature. So we just set the minimum neighbor to 3 and quite a tight zone to group those together because they're all templated, so it's going to work quite well and does. Then the spatial relator is used to then, as a within requester, see if that disabled symbol is within the circle to determine if it's a disabled access station, and we do that by using the related suppliers value. So if it's 1 or more, it means that it does. So using that as a conditional value, which you can see on the right, we then allocate and create that attribute. Then post this, there are still some in the geometry, the disabled stations, it's kind of like a layered circle, so they all read as individual geometry. So we just got to aggregate those, so it's a single geometry, and it's going to work and not create duplicates later in the process. So I just included the workflow here to give a bit more of a visual aid for explaining that, because there was a bit going on that might be a bit hard to sort of visualize. So what we've got is removing the N's and D's in the attribute filter from the counter that's just fed into it. So then we can get rid of those. And then the neighborhood aggregator at the bottom is what is aggregating the disabled wheelchair geometries together. Then goes through the spatial relator, and then the output of that is then going into the attribute manager, which is creating that disabled access attribute. Then when it goes from there, we're separating it so the ones that were yes can have the neighborhood aggregator applied, because the ones that no didn't need to it. And then they move off for further processing, where mostly they're just given a unique ID and they're joined together to create the layer stations with the other stations that we've processed as well. Now we will move on to how I created the zones. So first of all, with the zones, we have to isolate the area geometry to the particular zones. So again, classic case of going to the data inspector, using the area calculations and finding which zone component is the smallest. And if we can then do a test filter to filter out the geometries that are bigger than that, we've got pretty much we've got all the zones there, and then there might be some stray geometries, but we can work with that to get the zones that we want. So once we have that, we then put a counter ID on all those polygons, and then use an attribute filter to give each of those polygons an output port, because we're going to have to use those in multiple ways to produce the zones that we need. So with trying to create the zones, the use of the hollows has created an issue for us where I can't actually extract them as is. So you can see, like, for example, you can see on the left, there's zone 2 is highlighted in it, but you can see zone 1 in here. We need the donut of that, so that's not quite reading properly. And then over on the right, the zone 4 is highlighted, but zone 3, zone 5, zone 7, these are all hollows, so I can't actually extract those as is. So we need to find a way to get those out so we can relate them onto the stations properly. The solution we can have to get around this sort of hollow and geometry roadblock is to use the extent box that came with, that was read as the geometry, and then a combination of the other polygons in a clipper to then get the outside port. And then from the outside port, we manipulate that and create our own and build our own geometries that split it up. And then we can use a count attribute on an attribute filter to then isolate the correct zones that we want, like we've been doing previously. So once you've clipped it all up and you've got your right zones, you then have to recalculate the area because the polygons have changed from the clipping. and then again use those values to assign what the zones are. And then finally, I think it's just zone 7 that has 2 of its zones in the top corners of the PDF. You aggregate those according to the zone value to then get your final output. So just as an example, I've got here creating zone 3. So to create zone 3, we need the gap between the purple and the yellow. So when we've done the clip, those are the 3 clippers, and then the candidate that's come outside of it is the dark green. So we can see here, while it outputs 1 geometry, there's actually 3 components here. So once we put that through the area builder, they'll get split up into those 3 parts. Say we put a counter ID on it, and those are the ID attributes of 1, 2, and 3. It's number 2 that we want, so then we filter it out with an attribute filter, and then we pull 2, and voila, you've got zone 3. So zones 3 and 5 were quite interesting to deal with, because when I ran the clipper, it had the outside connecting to other zones, and I found out it was an issue with the geometries not touching. So what I actually did was I would just say that the top right is zone 7, but where you can see it's kind of gone across here, it's connected up, and then it's ran it through the rest. So that's creating some issues. So what I actually did was I applied a buffer on the top, the selected polygons, and that essentially ensured that it touches and it gets the clipping correct. So you can even see in that particular screenshot that the different color, so that's its own polygon there, that's another own feature there, and then that's all there as well. So it's representing properly. So yeah, so that's zone 7, that's zone 6, and that's zone 5. So it's correctly done. So now, bringing it all together and doing the conflation part. We want to essentially relate all the data sets together. So stations we're going to use as a central data set for merging. So essentially all of the different information that we've pulled out of the PDF is going to go onto the station data set. So the intersection, the spatial later was used for the intersections, and the neighbor finder was used for within distances. So the two different types of spatial conflations that we're doing, and the relations to be made was stations and the text tables and the names. So that was through the neighbor finder, and then the station and zones and tube lines are done with the spatial relator. And the key part being as well is generating the list of the conflated attribute, because the generated list is then what's used further on when you need to concatenate all that information. And in this particular one with the tube lines, you could actually use how many times the intersections happened as an advantage to count, to say how many tube lines the station serves as well. So once you've concatenated everything and you've turned that information into attributes on the station, we can then start using attribute managers and things like that to reorder the attributes, clean up some names and that sort of thing. I mean by naming of the attributes, not the actual names of the station, and remove some sort of stray duplicates that were sitting within some of the symbols. And once we've all done that, then you'll be ready to write it out to the GIS file. And then this is what it comes out in. So this is something I've just put up in QGIS, and then just applied a style that I saved of the different colors for the different lines. So you can see here that all the station markers are pretty much there. We've got the circles, this white for interchange lines, that where the two lines meet per se, as opposed to say here at Tottenham Court Road where they're on the different lines that are intersect. And yeah, that's pretty much it. And then we've got a little legend down here. So if we were then to put on the labels, I thought I'd just give you a bit of a laugh and zoom in. yeah, you can see pretty much that. You can see down here with Bermondsey and London Bridge, it's worked relatively well, but some of them are duplicated. It's quite, you're going to have to probably just spend, half an hour or so just going through and, um, yeah, fixing all that up. But then we can see on the information on the right, you've got your different attributes here. So yeah, it's got the station, what zone it's in, disabled access. I wrote it out to a shapefile, so that's why some of these are cut off. Probably not the best decision, but the rail line, so you can see it does intersect the Central line and the Piccadilly. The number of tube lines, and I thought I'd be trying slick and try and cover in some of the colors and fills, but I think with the shapefile and the software I made, it's not picking it up. But that is something you can do in a lot of them. So it's a good sort of, if you can figure it out, then it's quite slick. So the final product, some of the cleanups, some of them I've already alluded to, but then the data type widths is a bit of an issue, or something you can clean up too. So I was getting some issues actually with the 2/3 for zone. It wasn't set on variable character, but it was set on number. So those were coming through as null. So just fixing things up like that is quite important. And yeah, just little things like that that are sort of there. But on the whole, yeah, it's done geometry quite well, but text is just a bit of it requires very strict structure if you're going to be doing text. Quite hard at using the text anchors that feel like they're a bit randomly sort of distributed within a space. So yeah, from that I will leave it to questions.